Thanks. Well, good afternoon, everybody. It's great to see so many people here. It's a privilege to be able to speak to all of you about AWS. It's also a privilege that I have the revered after lunch graveyard shift. So I hope all of you enjoyed the lunch. And just so I know a little bit more about the audience, how many people are interested in learning more about disaster recovery on AWS? It's a bit of a trick question, just making sure you're not coming somewhere warm, although it's quite cold in here after lunch. And how many of you are using AWS in some way today in your organizations? Okay, a good mix. Well, my name is Paul Duffy. I'm part of the New York City-based solution architecture team. So our role is all around helping customers who are thinking of deploying applications on AWS. As Stelio said, bunch of content we've got in the presentation. We're not going to do a formal Q&A, but I'll be around to answer questions afterwards. And as well as that, a lot of the other solution architects are going to be here. They'll be at the booth. So if you want to go over any scenarios for disaster recovery or anything else that you think about doing with AWS, please come and talk to us. We'll happily talk to you about that. So for the perspective of this session, I'm going to spend some time talking to you about scenarios, a little bit of context of what's interesting about disaster recovery on the AWS cloud and so on. Look at some of the fundamental building blocks that AWS provides to make it straightforward for you to do disaster recovery on AWS. We also have a special guest, Keith Mead, our customer, who's going to talk through his thought processes and what they've done in their organization with disaster recovery. And then we'll signpost you to some resources and some kind of potential next steps to go on. So first of all, some context. Now, disaster recovery is not a new concept in itself, and every customer I speak to for the entire time I've been working in the software space has always talked about disaster recovery. So why are we focusing on disaster recovery in a session at this summit? Well, we like to think that we're customer focused here at AWS, and we asked you. So in a survey we did during one of our webinars, we were asking you what scenarios were important for you in terms of cloud thinking, and disaster recovery was one of the prioritized scenarios. And does this sit well with you in the audience? Does it make sense in terms of what you're thinking? Good. And then also to talk about why disaster recovery on AWS. So some of the fundamental tenets of AWS, low cost, elasticity, open and flexible, secure, those things apply very well to disaster recovery in particular. The traditional model for doing disaster recovery, and this was one of the things that Werner mentioned in his keynote this morning, a lot of the older models for doing things like that required significant amounts of expenditure, significant amounts of effort, because you often had to duplicate infrastructure and have very, very high fixed costs for infrastructure that you might not use. So some of these fundamentals, openness in terms of the choice you've got for things like the operating systems you use, or the flexibility to scale when you need more demand if you had a disaster scenario where you needed to fail over. One other very, very clear distinction I want to make before we go any further into the session is AWS also encourages some new types of thinking about high availability and disaster recovery. And this is exactly what Werner was talking about earlier. Back in the day, if you had a set of web servers or a web server that were running in one data center and you wanted to make that application highly available between different data centers, you had to go and find another facility. You had to go and pay for that facility. You had to do the work to provision that in different locations. With applications that are deployed, that are built with cloud principles in mind on AWS, it's very, very straightforward to deploy an application across multiple availability zones, giving high availability that might make people think differently about disaster recovery. That is not what this session is about, and that's something we want to make very clear. If you want to hear more about how to build highly scalable, highly available web applications, my colleague Miles at 2:45 is doing a session today, and that's where you should go if you want to hear about that. What we're talking about today, and one of the fundamental messages about doing disaster recovery on AWS, is it does not mean re-architecting. If you've got applications that you've had running for years, you've got storage systems you're using on-premise that you've been using for some time, the message is not saying you need to go and re-architect that to make it cloud aware for you to use AWS for disaster recovery. This session and the scenarios that we talk about here are all about taking the existing on-premise infrastructure. I'm sure it's in neater rows in your data center than it is here, but I thought I'd make it a little bit different. But it's about taking the on-premise infrastructure that you have, and using the capabilities that we see over there that we'll talk about when we're looking at the various specific AWS building blocks for disaster recovery, storage, load balancing, compute instances, and using those resources to take what you've got on-prem and use the AWS cloud for disaster recovery. It is not about saying that you have to re-architect things, and some of the scenarios we'll talk about in particular, it'll be very, very obvious, hopefully, how straightforward that is to do. So that's setting a bit of context about what we're going to talk about in terms of the scenarios. And let's start to talk about things related to cost and why we see AWS as being a potentially great thing for you to think of for disaster recovery scenarios. So here, on the left-hand side here, we have the kind of things that you might find in a pretty exhaustive list of the kind of things you might find in a production environment. On the right-hand side, we see the things you might typically find in your alternate DR site, another data center. And the spot the difference thing is because they're the same. Fundamentally, you've got to build those two things over to have the right kind of disaster recovery capability. If we think about that in the model of the way we think about things at AWS, that list starts to look very different. And now we're talking about the AWS cloud, or components within the AWS cloud being the DR site. And potentially, the only thing that you're paying for in some of the scenarios we're talking about today is storage of snapshots, storage of data. You no longer have to maintain all of this parallel infrastructure that you might not be using very often. And let's look at that a different way. So this graph we have here, the blue line across the top is showing the kind of costs for a second DR site, for the power, the facilities, the hardware that's been purchased and so on. And whether you use it or not, potentially there might be some variance depending on whether you've got all the infrastructure there running and consuming power. But fundamentally, that's not a very elastic thing. You've built it, you've provisioned it for exactly what you need if you had to, the worst case had to happen, and it's a flat line. We see in these curves on the bottom a demand curve, and that gap for the second site that you've potentially deployed, that gap's the same whether you use it or not. From an AWS point of view, as we look at the demand there, and we look at the cost for AWS services, and part of our fundamental model of paying for what you use, you notice that the cost very closely tracks the demand. One thing that we recommend is very important in any disaster recovery plan is doing the right kind of testing. So here we see a little spike when a test is happening, very, very baseline level of things. Potentially it's just storage. In one of the scenarios that we'll talk about called the pilot light, it might be running a very small, some small pieces of infrastructure. But you're only paying for what you use at that time. Then, should an unfortunate event happen and disaster strikes, then you're going to scale up that infrastructure. You're going to be using more resources in the cloud, but you're only going to be paying for them for the duration of time that you need them. There's no arbitrary window that says you've got to fall back to your own data center in a week. If it takes you a week to recover your site, that's fine. If it takes you 6 months to recover a site, that's fine too. If you choose not to recover a site and run all these applications on a longer term in the cloud, that's great too. But the key thing is here, there's a significant potential saving for doing this kind of thing in the cloud. So that's kind of thinking about it in terms of the kind of the economics and the differences in what you'd have to think about provisioning and so on. So what about how to do DR with AWS? So the next section of the presentation is going to be spending a little bit of time going into what the building blocks are, what the components of the AWS platform, the various services are that are most relevant for disaster recovery. Then we're going to introduce some scenarios that we talk about, and we also document these in a disaster recovery white paper that we have. So we'll talk about these building blocks, what they're used for, where they fit in, and then we'll go through a set of scenarios for disaster recovery with you, ranging from the very simple backup and restore to one we call a pilot light, to a kind of active-active type of model, and just go through some of the things to think about when you're preparing for deploying solutions like that, or at the time that disaster strikes and you need to think about doing some kind of failover. So to start with, Werner talked about this earlier today. This is a kind of a geographical picture of the infrastructure that we have, and it shows the various AWS regions. And the same kind of building blocks that you find in the region in the US East are typically the same kinds of things that you're going to find in the US West region or that you're going to find in Asia Pacific or Europe. So this also means that any disaster recovery solution that you build in the US, in a region based in the US, is potentially something that's very easy for you to replicate if you want to go and do a similar type of disaster recovery scenario for your facilities in Europe or Asia and so on. So this shows where those locations are. So this gives the flexibility of choosing where you want to do disaster recovery and making it easy if you do it in other places. From a security point of view, many security standards, we have white papers that document these, and we get a lot of feedback from customers that these make the customers feel good about stuff they're doing in AWS, whether this is looking at the certifications that we have by third parties who validate what we're doing, whether it's looking at standards we have for physical security, so very, very tightly controlled access to facilities, what you would expect for physical access being security controlled. I can't go into an AWS data center because I have no business need to do so. So very, very tight security and something that we document there. And then the other kinds of things that you'd expect from a kind of an enterprise-grade provider, data centers in nondescript facilities, and all the other things that Werner talked about this morning in terms of redundancy at the network level or the power level and so on. So what are the services that we're going to use in AWS from a disaster recovery point of view? Well, the first and most important one in the entry-level scenarios is our simple storage service, S3. And this is our internet-scale object store, where if you were just doing a simple backup and recovery and you were storing files that you'd previously stored on-prem in the AWS cloud, they're going to be in S3, very, very high durability. If a disaster occurs and they need to come out of S3, potentially that's when we're going to use the Elastic Compute Cloud. And that's our service that offers, and if any of you use, or some of you have said, if you're using AWS today, it's very likely that you're going to be using EC2 already, but EC2 is the core compute service we provide, and that's likely to be the thing that will be accessing your data that you've stored in the cloud for disaster recovery and letting you access it should a disaster occur. We also have something called import and export for getting large amounts of data into the cloud. Sometimes customers would transfer that over the internet or over a suitable secure connection. We also have an option for you to ship portable devices to us so they can be imported into the cloud without you having to worry about doing that over a network connection that's not fast enough, or it's going to take too long, or there's another reason that you might not want to do that. We also have an offering that Adam was talking about earlier called the Storage Gateway, which is making it even easier for you to download a software appliance into your on-premise environment, read and write stuff to that local storage gateway, and have that transparently sent back up into the cloud. And then when we start to talk about some of the failure scenarios if a disaster occurs, DNS is obviously a fundamental thing for many different kinds of applications from an availability point of view. And we also have a DNS service which you can use, very easy to control by the console or an API level, so that if a disaster occurred and you needed to swing traffic over to the disaster recovery infrastructure that you have in the cloud, it's very, very simple for you to do that. So those are the core building blocks that we're going to have in each of the scenarios that we're going to talk about. And that's the next thing that we're going to talk about in the presentation. So for each of these scenarios, we're going to overview what they look like before any kind of disaster, talk about the kind of things that you'd have to do to prepare, show what would happen in case of a disaster and how you would be able to transition from your regular on-premise production environment to your AWS cloud-based disaster recovery environment. Before we do this, just to redefine a couple of terms which I'm sure you're familiar with at some point, because we use these as we describe the scenarios. We're going through a gradient of very, very simple scenarios that are very easy for you to engage with, to more complex scenarios. And as you go from the simple scenarios to the more complex scenarios, there are various trade-offs to make for the recovery time objective, so how long it's going to take before normal operations are restored, and the recovery point objective in terms of the kind of data loss that you might be prepared to tolerate. Those things are based on what you're going to define based on your business needs. And we're going to show you how the different scenarios that we can do with the AWS cloud relate to doing that. So the very first one that we're going to talk about is backup and restore, perhaps the most simple. So we start out in the on-prem infrastructure that you have. It might be as simple as one server. It's probably going to be some more. And you copy that data up into S3, a variety of different ways that could be done. You could do it on an automated basis. You could do it on a manual basis. You could use our import-export service and literally ship it on some devices to us, and we'll put it into S3. And from that point of view, very, very little technical work you might have to do in the on-prem environment. This could literally be a logistical thing that instead of doing something with portable devices and sending them somewhere else, you could use the import-export service. Next thing, they're in the cloud, and they're ready for you to use should you need to do some kind of failover. So that's the most simple. Something that's related there is the storage gateway. Now, this is a very, very easy thing from the point of view that this is a software appliance that you download and deploy on your premises, connect it to whatever local storage you have, expose this gateway to other application servers via iSCSI in your environment. And then what's happening now is your users are continuing to read and write to this local server using the storage gateway. And the stuff they're doing with the storage gateway, that data is sent over to S3 and automatically stored in there with the same kind of durability you'd expect from S3. So a little bit more work to do because you've got to download this appliance and you're not just shipping a device over there. But from a transparency point of view, very, very little that users have to do. They just keep using that local infrastructure and it ends up being stored in S3. Now, in the disaster scenarios, what happens? Well, in either of these scenarios, we've got the data in S3. So say that we have a failure, and you lose a site through some kind of flood or some power outage or something that you can't recover from and you need to switch. Over in the AWS cloud right now, first of all, we're going to need some compute resource. So your data's already in there. So from this data that's in S3, from snapshots, as we call them, EBS snapshots that might be there, we can create a data volume. So your data is now accessible to a compute resource, and we need to provision an EC2 instance, effectively a virtual server that's running in the cloud for you to access that. Now, that's launched based on a template that we call an AMI, an Amazon Machine Image. How many people are familiar with AMIs here? Good, okay, so this should be fairly straightforward. So you've configured your AMI with whatever kind of applications that you need, so it's basically ready to go, and the only thing you're doing here is making sure that the volume attached is coming from what was stored in S3. The instance comes up. You may need to do some DNS changes to make sure that your users can access that application, and they're ready to go. So the most straightforward, you've got the AMI, so you need to do some work, and we'll talk about the preparation work to do, but you launch an instance off the AMI, attach a volume based on the data that you've been storing in S3, either via the storage gateway, via import-export, or via an automated process that you've developed, and you're ready to go. So what are the advantages of doing this? Well, very, very simple to get started. At the base level with the backup, if you were using import, you're just sending devices, and the data is going over there. So potentially, you don't need to make any changes to your infrastructure to do that. If you want to do it on an automated way, putting stuff directly in S3, you'd have to figure out what the right way is to do that, and we can certainly talk to you afterwards if you'd like to know more there. And extremely cost effective. When there's no disaster, what's happening in the AWS cloud for this scenario? Answer is nothing. You're not running any instances. The only thing that you're using there is storage. When you're thinking about what to do to prepare for this, clearly you need to take backups of current systems or work out how you're going to get the data there, import, export, or whatever. Also, the third bullet point, which sounds straightforward and may well be straightforward but is very important, you also need to describe the procedure to restore from that backup. So do you have an AMI ready and so on? Make sure you're ready. From the storage gateway point of view, it's also simple to get started and pretty cost effective. You download the software appliance from the AWS website, you provision it on an on-prem server, you configure the storage gateway, you use it. You also need to make sure that you've got the procedures to restore from the backup should a disaster occur, and you have to do that switch. So, in the case of disaster, to recap there, you retrieve the backups from S3, you bring up the EC2 instances, so you've prepared the AMI. If you decided that you needed to have 2 EC2 instances for the capacity for your application, maybe you need to bring 2 up. That's just going to be specific on your application. Restore the system from the backup based on the data that you've taken out of S3, and then switch over the new system using DNS. Now, we have this consistent thing through all of the scenarios. In terms of the recovery time and the recovery point objectives, how long does it take from an RTO point of view? I don't know. It depends how long it's going to take you once a disastrous event has happened to spin that infrastructure up, because this is the one where you're not paying for any infrastructure, so no EC2 instances are running when a disaster hasn't occurred. So you need to, first of all, spin that up to get the service available again. From an RPO point of view, when did you do your last backup? If you're shipping devices once a week, it's going to be once a week. If you're doing something on more of a kind of trickle feed model, it's going to be a kind of a shorter time. So that's the simplest scenario. The next one that we're going to talk about is known as the pilot light. So in the pilot light, and this analogy comes from furnace, you know, the kind of the gas burner in a furnace, as people in the US say, or a boiler in the UK. And in this environment, we've got a sample 3-tier application running in your on-premise environment with a database server, an app server, and a web server. And over in AWS, on the other side, and I'll walk to illustrate it, and it's also nearer for me to point, in the AWS side, we've got a database server instance that is running, and that's running all the time. And you can see with that line between your on-premise environment and the AWS site, some kind of data mirroring or replication is going on. We're not prescriptive about what that is, but the fundamental principle there is data is being mirrored or replicated between those two sites. We also have an application server and a web server instance, but they're not running. So in terms of the infrastructure that's active in AWS at any one time, if there isn't a disaster, the only thing you've got running there is the database server and the data being replicated across. So that potentially is going to be very up to date. In the case of a disaster, so you lose what's in your production environment over there, and within a very short period of time, using that pilot-like concept, those other pieces of infrastructure that were not running in the cloud are now running. So the application and the web server have come alive. DNS has failed over. We're demonstrating in this case using Route 53. And users are now able to access that new application. Well, they're able to access the DR site pretty seamlessly. The only change to the infrastructure there is that we had to start up the application server and the web server. So what's good about that scenario? Well, it's potentially very cost effective, because the only resource that you've got running 24/7 there is the database instance. You're not running the full stack, you're just running a database instance. There could be a smaller instance than that you need in production as well. What do you need to do from a preparation phase? Well, you need to enable replication of the critical data of that database into AWS. And again, we're not prescriptive about exactly which method that you'd use to do that. Lots of ways to solve that problem, but you need to do that. Then prepare all of the required resources for an automatic start. So the same kind of things, the right AMIs for your application server tier or your web server tier, network settings. If you think that you might require more than one web server, if you think you're going to need to do some kind of load balancing, you're going to need to configure that kind of stuff ready as well. And then the other thing you may think about is purchasing reserved instances, so you make sure that capacity is there when you need it to start that. So in the case of a disaster, what do you need to do? So the database is running. Database should hopefully be pretty up to date, depending on what what kind of replication or mirroring configuration you've got for the database. So what do? Automatically bring up the resources around that replicated core data set. Scale the system as needed. So you might be running a smaller database instance when you're not in a disaster scenario and decide that you're going to scale it up. If a disaster occurs, it could be that you're going to run a larger one all the time. Those are just choices that we give you to make with the building blocks. And then switch over to the new system by adjusting DNS records. How do you do this? A lot of that is depending on what you want to do in your environment. You know, these instances could be ones that are in the console that are stopped that you start. You could have an automated way to do it. Very, very easy to automate this stuff with AWS, because you can do so much through command lines or through various APIs, through the various SDKs we have. So very much something we'd encourage you to do in an automated fashion. And then from an objectives point of view, the RTO, how do you detect that something bad has happened? How long is it going to take you to detect the need for disaster recovery and then to scale up that replacement system? And then from a time point of view, it's pretty simple really. How are you doing data replication? You know, you're doing something once an hour, are you doing something on more of a kind of a mirroring basis? But that's the thing that's going to answer that question there. The next scenario we have is the fully working low capacity standby. So this is building and getting a little bit more complex than the previous pilot light scenario. So what we have here now is a database server, an application server, and a web server, just as before, running in your on-prem environment. And over here in the AWS cloud, we have a database server, an app server, and a web server, but they're smaller versions. So this time, you now potentially have 3 instances, or depending on the scale of your architecture, some more. You have all of these instances running all the time inside your AWS cloud environment. We still have the data mirroring or replication that's happening between your data center and the cloud. But this time, as we've depicted at the top with Route 53, we are having some capacity potentially being served by this environment in AWS. So potentially we're using that to make sure we're comfortable that the application's always working and it's always up to date. Potentially we're using it to take a little bit of load from the system that's in on-prem. But this is, the low capacity standby is working and available throughout the stack. All of those instances are running when we look at them. It's not a question like with the pilot light of them being stopped and having to do something to start them. So what happens in case of a disaster? So something bad happens to a data center, all your on-premise infrastructure dies. And through the kind of elasticity that we have, we now scale the capacity of those instances up. So we now have a bigger database server, a bigger application server, a bigger web server, or maybe it's a scale-out thing and we have more of them. The concept is really that you're going from sizing for not having to take your full production capacity to sizing up when you do need to do that. And ultimately, DNS will be switched over, so all the traffic is now going to that site. From the point of view of advantages, it can take some production traffic at any time, so maybe it might be useful from a capacity point of view. Still good from a cost-saving point of view. The IT footprint is smaller than the full DR thing that we talked about before, where you're potentially talking about the whole thing being replicated between one site and the other. And what about preparation? So some of it is very similar to the pilot light thing. You've still got to do the right kind of things for AMIs, provisioning machines so that those instances are running the correct version of your application. You're potentially doing things like patching them and making sure that they're ready to run. But this time, all of those components are running 24/7. They're just not scaled for production traffic. And one best practice we have is for continuous testing, so you're confident that that application, you're trickling some traffic over there to be confident that everything is working as it should. In case of disaster, in this sense, it's simpler and it's potentially quicker than the pilot light scenario because you first of all fail over the most critical production load, just DNS to point to that, and then scale the system to handle the additional traffic. How might you scale that? You could do it automatically from a scripting point of view. You could do it manually. Many ways you could do that from a horizontal point of view. You could use things like auto-scaling. But you need to do that work because the proposed architecture here is you have a small version of the architecture running, not something that is ready to handle all of the capacity all of the time. From an objectives point of view, the RTO is how long the critical load fails over instantly. The other load, how long is it going to take you to scale, whether it's horizontally, whether it's scaling vertical? That will give you the answer to that question. From a recovery point objective, this depends on the type of replication, the same kind of thing. Presumably, you're going to be doing replication on more of a kind of a mirroring or very, very low latency kind of thing because you've got traffic going over there all the time. The last scenario that we have here is one that we call the multi-site hot standby. So this is conceptually pretty easy to understand. This time, in your environment, we have the web server, the application server, and the data center, the database server all running. In the AWS cloud, we have the web server, the application server, and the database server running. This time, ready to take full capacity with whatever kind of data mirroring or replication that's going over there. And here we don't have a slide for failover because there is no need to necessarily do a huge amount of different things if a disaster were to occur. So you lose your infrastructure through some flood or some power outage or something like that in your own data center. You've already got full capacity infrastructure ready in the AWS cloud to take over that traffic. If you needed to grow that still further, very straightforward with AWS to do that kind of scale. So from an advantages point of view, at any moment, this can handle all of the production traffic. Preparation, similar to the low capacity standby, you still need to do the right kind of thing in terms of building that infrastructure, the right AMIs, managing those instances to make sure that they're ready and running your application. And in case of disaster, failover straight away. Adjust the DNS records because you don't want any traffic going to the production site that's no longer working. And then from an objectives point of view, really, the RTO is as long as it takes to do the failover, and the RPO is going to be dependent on the replication type, which in this kind of environment, you're assuming that's going to be a very, very small number. One of the really fundamental things here about DR, how many people have a DR plan in place now? How many people test it regularly and feel really good about testing it regularly? And this is something that, I started my career working out for a very, very small reseller. And I remember selling an insurance agent who was religiously backing up every night onto tape. And I'm sure you can tell what's coming next. And his server was stolen from his small office. His tapes were in a fire safe. And they were as empty as they had been the day he took them out of the box. And I thought that was only a small company thing. But as I've spent more time, a lot of people don't test DR plans well enough. If you read our white paper, we call it in there the concept of the game day. But it really is important to test. Especially if you're looking at some of these scenarios which the pilot light option potentially gives you really, really good cost savings because you're only running a small amount of infrastructure. But you do have to do stuff to, when the pilot light ignites those other instances and they come up and they're ready to serve the application, you need to make sure you feel comfortable how that's done. The last scenario that we talked about there, basically the full capacity on either side, from a mental model point of view, that's a lot more like some kind of hot failover thing that people are used to now. But if you're doing these pilot-like things, or you're doing the small standby that you need to scale up, that you need to increase capacity, it's really important to make sure you're testing that. Not just that you've gone through the procedures, but do this kind of game day thing, as we call it in the white paper, and see that you're comfortable with it. And one of the advantages, if you remember the graph that we showed you at the start of the presentation, is you're not paying a huge amount for this thing all the time that's just sitting idle. If you want to do a test, the cost of AWS for the small test that you do will go up and then will go down when the test has been completed. So even easier with AWS to test than it might have been with more traditional environments. But please, if there's one thing that you take away, if you look at any of those scenarios, please do the right amount of testing. So those are the canonical scenarios. These are consistent. If you want to know more about these, if you read the white paper we publish on the website, none of these scenarios should be news. They're all the same consistent set of scenarios that we talk about when we're talking about these disaster recovery scenarios for using the AWS cloud to back up your on-prem infrastructure from a disaster recovery point of view. And remember, if you want to know more about the model for new applications and high availability, that's going to be in the other session that my colleague Miles is doing. So that's the end of the scenarios. That's me talking about it. But rather than just listen to me talk about it, what I'd like to do now is invite Keith Mead, Senior Account Director from one of our customers, WhatsUp Interactive, on stage, and he's going to talk through the thinking that went through the minds of people at WhatsUp and their experiences doing DR with AWS. So please welcome Keith.
I am Keith Mead at WhatsUp Interactive, Senior Account Director. My contact info is there. Just a little bit about WhatsUp Interactive. I won't go into the name. That's another story for another day. But we are a digital agency in Atlanta, Georgia. We try to strive to be the single point of contact for our clients. So that means across marketing, across creative, and across technology, we want to be able to be their sole contact. And in the technology world in which we live in, I often call it's the silent given. Our clients want it up, and it always needs to work, the end of story. So that we have to make sure that we provide that level of service. Just a sample of our clients, we have Fox television stations, AT&T, DS Waters, and the Georgia Lottery Corporation, as well as Georgia Aquarium. We also have what we call growth businesses. They're going to be your B2B businesses more often in Georgia, in the Atlanta area, that are looking to just build their web presence. And so we are actually dabbling in a lot of the different scenarios that Paul has illustrated earlier for our clients and how they can leverage disaster recovery services that before was not really available to them. I want to just take a moment and highlight a story about, with the Georgia Lottery Corporation. You guys may have remembered the gigantic jackpot that we had, maybe 2 weeks ago, $640 million. Any of those that played or in on that ticket? So we were using a kind of a low capacity solution with AWS for the Georgia Lottery Corporation. And the testing scenario is very, very important. We actually spent the 24, 48 hours before this big jackpot kind of testing out how we could use our DR instance in AWS for it. And if you are familiar with Google Analytics and the live view, I just want to kind of showcase some numbers. I tend to like a lot of numbers. We knew that going into it, the highest jackpot, the highest number of visitors at any one moment that we've ever seen was right at 7,000. This number was the active viewers before the draw actually happened. So we knew going into this, our numbers in terms of what we were predicting were probably going to go through the roof. We were anticipating a load of maybe 14,000 active visitors at any 1 minute or any 1 second. We're already starting off at almost half that. And then we sat and watched. Numbers went 11,000. And this is a span of just maybe a couple minutes. Then it jumped to 24,000. And then at that 11,000 number, those were the benchmarks that we were anticipating. We were guessing in the office somewhere between 11 and 14,000 was where we were going to end up. At that point, we had to drastically scale up the instance we had in AWS, and it allowed us to hit the high point of 35,000, and that was within 25 minutes of the draw. So the DR site helped us a good deal during that jackpot. Just to kind of back up, our experience in AWS really started from that internal backup solution for all of our production service, all our production team. Every day, day in, day out, our team is doing creative, our team is doing new code, we have code repositories, and all that needs to be working and accessible in order for our business to continue. And disaster in Atlanta can be a couple of snowflakes or a snowstorm. And so in the first week of January of 2011, our office was basically closed due to a snowstorm. We were not able to get to the office. So we were reevaluating our disaster recovery scenarios, and in April we started using AWS for that, so that our team, if need be, can access everything from the cloud and allow our team to continue to produce what we have to produce every day. From there, we started to look at how can we actually provide a better service for our clients using the same services. So we began to take snapshots of different sites that we host, different production systems that we host, and begin to store that into the cloud for additional ways of backup and very quick recovery times. And from there, this is what we're working on this year, is basically looking at different clients that we have and offering kind of the pilot light or low capacity solutions to the different clients that we have. And I think one for us to showcase is a client, DS Waters. The brand is Nursery Water. It is important this site remains up all the time. They do a daily giveaway of a free bag that customers go crazy for, and it's important that site's always up. So we've always had discussions with them in terms of DR, and if you remember Paul's slide, one production system, in order to have full redundancy, you basically have the cost of duplicating your cost. And AWS kind of eliminates that factor. So we were able to provide a cost savings to them of over $2,500 a month without having to have a redundant system that they always need, always available, and just basically scale to AWS when they need it. So we are working on a program that kind of allows having conversations with our clients to figure out what is the best model for them. This is a complicated chart that I won't go into, but we're basically trying to, we have a wide variety of clients and trying to figure out what's the best scenario for them in terms of DR and scalability. What we learned, it took a while for us to get comfortable with it. We had lots and lots of conversations in the office of, will it work? What are the hurdles? What's it going to cost? And really the best thing I can do is encourage you to kind of do the same thing we did. You really just have to start with it. Pick a project, get into it. You really can get a good understanding of how it works. Cost was a big thing for us to kind of figure out. What's it going to cost? What's it going to cost to run a couple of days? And you really get good clarity once you run your system, get it in there for a couple of days, and then you really see how it works. Echo the same comments, test and test again, and test and test and test. You want to be able to know how your system will perform, how data replicates in between and out of different production systems, making sure that you have everything ready to flow in the event that you've got to use your systems. It really helps us to kind of realize the potential that's there. I think I go back to the story with the Georgia Lottery Corporation. As we were going through the scenarios of testing it, and as we see the jackpot continuing to rise, we got really confident really quickly with what we were able to do with AWS. So being able to use that as an option helped us scale a great deal. And I think with that, I'm going to hand it back over to Paul. Thank you.
Thanks very much, Keith. Hope everyone found that useful. And talking of the lottery, how many people entered that monster, mega, whatever it was called last week? How many people won big and are still here? I would be, had I still won big. Wouldn't miss this presentation for the world. Of course, that's true. One of the other things I wanted to pick up on from what Keith was talking about, though, and this is connected to some of the things that Werner was saying this morning, that we focused very much in this presentation on how you can use AWS to do DR for existing systems that you have on-prem without having to go and do re-architecture and that kind of thing. But the AWS cloud, in some of these scenarios, also gives you the ability to do more stuff. So in that kind of full capacity standby, it also enables you to potentially take more traffic in an elastic nature from the cloud, even in a time when you're not re-architecting stuff. So really, 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 really powerful, we hope. So we don't have much more to cover in the presentation today. We want to point you to a special section on the AWS website we have, which is just about disaster recovery. And if you go there, you can find the disaster recovery white paper we have, which goes into a lot more technical detail about all of the scenarios that we have and examples of how that you can do them. You'll see videos, case studies, and those kinds of things as well. One question a lot of customers have when they're thinking about implementing is, these things may be complicated. How can I get help? We have a strong ecosystem of partners, particularly in the storage space. So any of these partners, some of whom are at this conference, and you'll be able to go and talk to them, or come and talk to some of us at the Solutions Theatre later on, or just after the presentation, and we can give you more information. But they'll all be really keen to be able to help you out with some of those scenarios. And then the final thing we'd finish off from the point of view of a call to action, I would encourage you to learn more about DR resources. Evaluate using AWS for a disaster recovery project. Some of the things Keith was saying, really start testing. Some of these first steps are very simple. And please, whether it's on the presentation, whether it's on making disaster recovery scenarios easier for you, please do give us feedback. We aim to be a very, very customer-focused or a customer-obsessed company, so please do that. And then I would just finish by saying thanks very much for your time. I hope you found it useful. We'll be happy to do questions one-on-one here or in the Solutions Theatre or outside now or later on in the conference. So hope you've enjoyed it so far. Enjoy the rest of the summit. Thank you very much.